All right, guys, I've got three slides for you in this little block of slides. The first one is a little bit of a reminder, and it does come up in your textbook at this point as well, but it also flows into the energy balance by latitude. I particularly like this diagram because it really gives you an understanding of how much energy is coming in, relatively speaking. So when we have a 90-degree incident rate, so we're hitting this square on right here, think of the ratio here as how much energy is left as you move up. All right, it's not quite, 75%, 75% of the original or 40% of the original volume that you're getting down here, but it's a nice visual, and if you are numerically minded, it kind of gives you a number to put with how much energy is actually lost by moving up in latitude. All right, so what we get is the same amount of energy every 12 hours at the pole. We get less energy in the mid latitudes, here and here, for instance, um, over the course of a year. And that changes, right? In the summer, you're going to get more because it's more intense, and not so much intense because the intensity hasn't changed. These angles remain the same, but the duration is longer. You have longer days, right? And then even though we're less intense up here, we've got super long days. So this is sort of like managing the budget of your bank account, right? Like how much money can you spend before the next infusion of money you're going to get with a paycheck or with a student loan, or your family is going to fall into some money, and maybe you're lucky and somebody's giving you money every week and every month, or a grandmother gives you some money once in her lifetime. But down here at the equator, we can count on nice intense energy every 12 hours, which means these organisms that exist right in here don't have to work too hard. They don't have to adopt storage mechanisms for their reproductive mechanisms and respiration and other functions over low energy times of the year and deficit energy times of the year. So that's really kind of critical. Here we're kind of looking at a diurnal or a 24-hour cycle. Certainly as we go up, the time frame becomes greater. So really we're looking at 6 months of sunlight, 6 months of absence up here. So you really have to bank that energy for a long period of time. And again, you know what? This is a really skinny bank account. And I know as students, you can appreciate there's no money in your pockets, right? So you're kind of like the North Pole. I don't have a lot coming in and I have to make it last for a really long time. So if we graph that out, it kind of looks like this. And this is a graph that shows us a diurnal cycle or day to night cycle. So I've got midnight through sunrise, noon, sunset, and midnight. We're going to do this daily pattern because there is a gain over the daylight hours and then a loss over the evening hours, and we see that in temperature fluctuation. But we're going to then translate this, and I'm going to have you write it in your notes, because I really believe in tactile learning. I'm a tactile learner myself. So the more you're using all of your senses, the better your learning skills are going to be. So we're going to transfer this into a whole year in a moment here. So we're going to take this as sunrise. Let's make it 6 o'clock in the morning. We're going to have noon, 3 o'clock, and then 6 o'clock at night, and then 12 o'clock at night, 12 o'clock at night. All right, guys? So early in the day, we don't have a lot of sun happening, but the volume of sunlight, the volume of energy starts to amass, and we end up increasing the volume of energy until about 8 o'clock or so. All right, so this is the equivalent of the volume of energy. what we can measure. The purple line is the temperature. So we can see that even though we've got solar energy coming in here at sunrise, it's not until right about here, after we've amassed some volume of energy, before the temperature starts to increase. And so around 8, 9, 10 o'clock, the temperature is rising at about the same rate that we are increasing the volume of energy which we are storing, all right, at our particular location in time. We reach noon where the sun is at its apex. So at noon we have received, under this bell curve, 50% of the total volume of energy that we're going to gain for the day. All right. At noon, now the sun starts to set, right? At first it's almost negligible. It's hard to see. You can see this curve isn't so great, but now we start to tip around 3 o'clock, and the rate of descent is quite substantial. So, but as we're gaining less energy, we're still gaining, but we're not gaining it as we're dropping off in the volume that we're gaining. We are still increasing in temperature, and we increase until about 3 o'clock in the afternoon. We have this lag bit right here from the apex of our total volume of sunlight through to here. And if we were to take this line down, we're at about 70 to 80% of the total volume of sunlight that we have stored, solar energy, insolation, that we've gotten for this time of the day, all right? Most of it. We have been releasing this energy starting about 8 o'clock and warming up the atmosphere as we released energy, but now we've got a lot of energy that we can release, and we're releasing all this volume of energy as the temperature starts to increase. At about 3 o'clock now, we've got less energy available to release. But we're still releasing everything that we have stored from sunrise on through to getting close to sunset. We are still releasing that, so it's still nice and warm. After sunset, we're not gaining any more energy, but all of this stuff, remember those nice hydrogen bonds, is we're re-releasing that stuff back into the atmosphere, and we're warm, but we're starting to cool off. And as there's less and less in our account, like our bank account, as there's less and less available here, there's less spending, so less temperature occurring. And your bank account, just like the sunlight account, is dwindling, 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 dwindling until we start to see the return of money, aka sunlight, where then when we have enough in the account, we can spend it as heat units again. All right, so there's a 24-hour cycle as is diagrammed. We can change this to an annual cycle. Think of the Northern Hemisphere. In the Northern Hemisphere, the sun returns to the equator, which is sunrise for us, on March 21st. We come through March, April, May, June. June's the longest day of the year. We're getting the most volume of sunlight. This is the same as noon. On June 22nd and 23rd, the days get shorter and shorter and shorter. But guess what? July and August are still warm, right? August is often the warmest time of the year for us. And because we've taken all this energy from March through to August, and we're releasing it back into the atmosphere. So we're still releasing energy, even though we're gaining it at a slower rate, until we reach September 21st, 22nd, the fall equinox, where the sun is at the equator. And from fall, now we move, or pardon me, from September, we move into fall, where the sun is now in the southern hemisphere. And so we go from September, October, November, December, shortest day of the year, the winter solstice. The temperatures are pretty cold. November is kind of warm. October's kind of warm. If you like to go out and camp in the fall, it's a great time to do so. The temperatures are really pleasant. We're out here now in January. We're sitting out here somewhere, you guys. Temperatures are still falling statistically across the planet. Some places I know are warmer than others. There's some regional variability there. But February, I think we can all agree, is still pretty darn crummy. Like, it's yucky. My least favorite month. Until we get to March 21st, 22nd, we start to get a little peak of sunlight back, and by the end of March, early April, the temperatures start to rise again. So the same pattern of collection of insolation and then release of heat units, the pattern is the same whether you're talking about a 24-hour cycle or you're talking about a 12-month cycle. All right, couple more slides and we are good to go.